Dear friends, please subscribe yo.com and press the bell button for recent updates. Thank for watching.
Welcome students. So in this session we are going to study the pin description of 8051 microcontroller. In the last session we were studied the architecture of 8051 microcontroller. That means the building blocks of 8051 microcontroller. So here we are going to see the pin diagram, okay, the pin description of 8051 microcontroller. Okay, let us enter into video.
U.com.
So before seeing the pin diagram, we must know some the projects that is based on 8051 microcontrollers. See the diagram here, one PCB port along with microcontroller 8051 microcontroller, then one LCD display, okay, then one sensor, that is ultrasonic sensor. This is a ultrasonic sensor. Actually this is ultrasonic sensor. This is a microcontroller, Atmel 8051 microcontroller. This is a LCD display, okay, this is a relay. Here some capacitors and some voltage regulator circuits are there. Here the switch is present, okay, right? So actually this is one simple project, actually ultrasonic range or distance finder using 8051. So by using this microcontroller based project, we can find the distance. Okay, ultrasonic range finder system consists of ultrasonic sensor with operate like a sonar technology. The system consists of 8051 microcontroller, LCD display and ultrasonic sensor. So by using this we can find the distance behind. So is there any obstacle present inside this sensor, it will find how long the obstacle is present, okay, right? So very smaller size, it can run in battery, okay, so smaller size, very reliable, okay, right? So very super project. Actually microcontroller based project is always better because it is a small in size, low power, high accuracy. There is high accuracy, then there is no for example, how can I say, that is very accurate and do not change the performance, okay, always it's produce a common result, okay. The next one is a water level indicator kit. So this kit is used to indicate the water level in our water tank, okay. This system monitor the water level in the tank and automatically switch on the motor whenever tank is empty, okay. So very simple project. The size is very smaller size, okay, based on 8051 microcontroller, okay, right? And this is also has a LCD display. Then next one is a solar panel sun tracker. So this is also microcontroller based solar panel sun tracker. So here this solar panel tracker is a sun tracker system for solar panel to achieve maximum efficiency. The system consists of two LDR which has to be mounted on the sides of solar panel. Actually this is a motor. Actually this is one of the stepper motor. This is a microcontroller IC and this is some latches, okay. Here the power supply section and some connecting wires with the sensors. The sensors is connected with the solar panel, okay, that is a LDR, light dependent resistor. So according to the light it will automatically change the solar panel towards the sun, okay, right? So likewise we can see another one project, that is a RFID based access control. RFID based access control can be implemented in school, colleges, office and so on. Nowadays RFID tags are associated with ID cards. Each tag has a unique ID which can pick up by the RF reader Our system consists of such RFID reader which operates in 125 kilohertz. Okay, so actually this is a RFID reader that is connected with a microcontroller. This is a microcontroller IC, this is also a display, and this is a relay, and this is a power supply circuits. Okay, right. So the same board and same microcontroller and same components can be used in different projects. Okay, we can change the programs only. So this is the applications of microcontroller. Okay, right. Next we are going to say the architecture. What type of architecture is present in 8051 microcontroller? That is a hardware, not hardware, hardware. That is a hardware architecture. Then what is another type of architecture? That is microprocessor architecture is von Neumann architecture. Microprocessor architecture is von Neumann, N-U-M-E-N, Neumann architecture. But microcontroller is a hardware architecture. What's the difference between these two? Microprocessor architecture that can access the program and data from same memory, but hardware architecture has separate program memory, separate data memory, so it can increase the speed of data transfer from memory, so the microcontroller unit can execute the program in a faster. Okay, that is a hardware architecture. Advantages. Okay, speeding up the data transfer rate. Then someone said permit the designer to implement different bus width and word size for program and data memory space, so we can change the bus width and word size. Okay, right. Next we are going to see the 8086 CPU operation. First we are going to see the features of 8051 microcontroller. Second, pin diagram. Okay, right. Then block diagram, that is already we have studied. Okay, first we are going to see the features. So the features of microcontroller, that is this introduced by Intel, referred as a MCS 51 microcontroller system, that is 51 in 1981. It is released in 1981. Okay, very old. So 8051 is a 8-bit controller, 8-bit processor. It has 8-bit processor inside. Okay, the ALU is a 8-bit. Okay, right. Then the CPU can work on 8-bit of data at the time. 8086 microprocessor is a 16-bit microprocessor, but 8051 is a 8-bit microcontroller. The 8051 became widely popular after allowing other manufacturers to make and market any flavor of 8051. So widely popular. Okay, after allowing other manufacturer to make and market any flavor of 8051 microcontroller. Okay, so 8051 microcontroller is used in so many projects. Okay, in student projects, in industry projects, okay, etc. Okay, then features. Okay, so it is a 8-bit. 8051 is a 8-bit microcontroller, and internal memory is a 4 kilobytes, okay, of ROM and 128 bytes of internal RAM. Okay, it has 4 8-bit port. Okay, so totally 32 IO lines present. It has 16-bit to number of 16-bit timers. Okay, on chip full duplex UART. Okay, that is a universal asynchronous receiver transmitter. Actually, synchronous receiver transmitter, that is for serial communication. Then it has 5 vector interrupts. Okay, then on chip clock oscillator is present. Then address bus is a 16-bit. That is a very important. Address bus is a 16-bit. In 8086 microprocessor, address bus is 20-bit, but 8051 microcontroller address bus is 16-bit. So it can access 64 kilobits of external code memory and 64 kilobits of external data memory. Okay, 16-bit program counter is used to access the external code memory, and a 16-bit data pointer that is used to access the external data memory. 128 user defined flags is available. So flags means that is used to indicate something in a program execution. So it is in microcontroller we are having 128 user defined flags, so we can define a flag according to our applications. 32 general purpose register, each of 8 bits. Okay, general purpose registers are 32 number of 8-bit general purpose register is present, that is used to store the data temporarily, that is act as a RAM. Okay, right. Next we are going to see the some details of 8051 family. So it is 8051 is the sub of the 8052. 8031 is a ROMless 8051. 31 is a ROMless, that is no permanent memory in 8031. Okay, so we can add external ROM along with the 8031. You lose 2 port and leave only 2 port for IO operations, because the ROM is connected in external means, so we have to use one port for address, another one port for data. Okay, then features, that is 3 different microcontrollers, all are same category. So 8051, 8052, 8031. So ROM is present. Okay, that is ROM availability of 8051 is 4K, 52 is 8K, 31 is 0K. RAM is 128 bytes in 8051 and 256 byte in 8052 and 128 bytes in 8031. Okay, then timer 2. Okay, in 8052 only we are having 3 timers. IO pins are 32, so in all we are having 32 IO pins. Serial port is always in all the 3 models 1. The interrupt source is 6 and 8052 has 8. Okay, so the 8052 has some advantage more than 8051. Okay, right. Then next we want to see the pin diagram. This is a pin diagram. So pin diagram means the real view of it IC. Okay, so what are the terminals present? Actually here we are having 40 terminals. Okay, 40 terminals. On one side we are having 20 terminals, another one side we are having 20 terminals, totally 40 terminals. So what are the uses of 40 terminals? Okay, so we are going to study today. And it's a block diagram already we have studied. Okay, right. Then pin description. So 8051 core member is 8751, 89C51, 8671. Okay, these are the same pin diagram. Okay, right. Have 40 pins dedicated for various functions such as IO, read, write, address, data, and interrupt. Okay, so totally 40 pins. Some pins having multiple functions. Some pins or some terminals having a single function. So come in different packages, such as, what are the packages? Okay, so packages means the structure of the IC. Okay, that is a DIP, Dual Inline Package. So Dual Inline Package means in a faster slide I think you saw that is a black color lines, black color IC, that is a Dual Inline Package. Then QFT, Quad Flat Package. Quad flat means it is looking like a square. Okay, square shape. In all the sides we are having the pins in horizontal lines. Okay, so in dual inline package we are having the pin is like this, vertical lines, but in QFT the pins are horizontal line. Okay, right. And another one format is LLC, leadless chip carrier. Leadless means there is no leads. Okay, so that is some just like a memory card. In a memory card we are having no leads, so we just insert. Okay, right. So likewise. Okay, these are the 3 different formats present in 8051 microcontroller. Okay, some companies provide 20 pin version of 8051 microcontroller. In 20 pin that is used for smaller area. Okay, some particular applications we are using 20 pin. In 20 pin we are only we are having 2 ports are removed. Okay, totally we are having the 4 number of port, but in 20 pin version only we are having 2 ports. First one is XTAL 1 and XTAL 2. 8051 is an chip on-chip oscillator, but it requires an external crystal to run it. So it has a inbuilt oscillator, but the oscillator needs the crystal externally. So the quartz crystal oscillator is connected to input XTAL1, that is a pin number 19, and XTAL2 pin number 18. In pin number 18 and 19 we have to connect, that is a crystal oscillator. And the next one is a quartz crystal oscillator is also need to capacitor of 30 picofarad value. So not only we are connecting a crystal, along with the crystal we are connecting capacitors of 30 picofarad. Next is the original, the 8051 operator is 12 megahertz. The frequency of 8051 is 12 megahertz. Okay, so this is a diagram, circuit diagram of the crystal along with the capacitor. Actually this is a XTL1 and XTL2, that is a pin number 19 and 19 and 18. So here that is a ground. So the crystal is connected between the pin number 18 and 19. Okay, so from pin number 18 and 19 we are grounding the capacitor, 30 picofarad capacitor, like this. Okay, right. Next one, the continuation. If you use the frequency source other than the crystal oscillator, such as TTL oscillator, so it will be connected to XTL only. Okay, XTL1 only. Okay, and XTL2 is unconnected, that is no connection. If you are using external clock, that is a TTL oscillator, means you have to use XTAL pin only. Okay, like this. The external oscillator is directly connected to XTAL. Okay, at the time XTAL2 is no connection. The next pin is a RST, that is a reset. So the reset pin is active high, normally active low. So upon applying the high pulse to this pin, the microcontroller will reset and terminate all the activities. So it is a reset. If you are in our computer, we are having the reset pin. If we are pressing the reset, it is automatically stop the current operations and it is entered into default level. Okay, the fresh condition. So this option referred to as a power on reset. Okay, activating the power on reset will cause all the values of register to be lost. Okay, if you are typewriting, if you are typing some content in our computer, suddenly your friend reset your computer, what will happen? All the information you were typed are lost. Okay, right. So what happened after reset? The reset value of some 8051 registers. Okay, so actually PC means program counter, that is set to 0000. TPTR, that is a data pointer, that value is also 0. Then accumulator ACC, that is also 0. PSW, program status word, that is also set to 0. Stack pointer, that is set to 07. Okay, then B register, that is 0. Then port 023, that is a 4 port is set to FF. Okay, so this is a condition after applying reset. Okay, we must place the first pin line of the source code in ROM location 0. Okay, right. Then EA, external access. So what is the use of external access? External access is a input pin and must be connected to VCC or ground. Okay, it is a input pin, it must be connected any one of that is VCC or ground. 8051 family members all come with on-chip ROM to store program and also have an external code and data memory. Okay, so 8051 family members all come with on-chip ROM. In 8051 we are having on-chip ROM. If you are not having on-chip ROM, our on-chip or our on-chip ROM is not enough to store our program, we have to connect external memory. So if you want to connect the external memory, at the time the external EA pin is connected to VCC. Okay, normally EA pin is connected to VCC means that is access the internal data. If you are connecting EA is to ground, that means the external memory is going to be accessed by the microcontroller. EA pin must be connected to ground to indicate that the code or data is stored externally. That is the point. Okay, right. Next one is a PSEN and ALE. Okay, what is PSEN? Program store enabled. It is an output pin. It is an output pin. This pin is connected to OE of the external memory, OE pin of an external memory. Okay, right. So that is a PSEN, program store enable. So this pin is connected with the OE pin of the external memory. So for external code memory, PSEN equal to 0. Okay, external code memory, the PNEX equal to PSEN equal to 0. For external data memory, PSEN equal to 1. Okay, so the ALE pin is used for demultiplexing address and data. ALE means address latch enable. That pin is used to demultiplexing the address and data. Okay, right. So ALE is a address latch enabled. Okay, it's a very important question. What is ALE? What is the use of ALE? Okay, then next one is the IO port of 8051 microcontroller. So actually we are having the 4 IO port. That is a port 0. These are the port 0. Port 0 is act as a address and data lines, and port 1 is a normal IO, and port 2 is a address lines, and port 3 is used for different control lines. Actually the port 1 is only a single action, this acts as a simple IO. Remaining 3 ports are assigned for multiple operations. So port 0, port 2 and port 3 is used as a basic IO. In some case it is used as a multiple operations. Sometimes if you are want to connect external memory, means port 0 provide address and data, port 2 provide higher order address. Okay, right. Port 2 is only for address, and port 0 is used for address and data, and port 3 is used for the control signals. Okay, read, transmit, interrupt 0, interrupt 1, timer 0, timer 1, read, write, etc. These are the control signals that is used in port 3, but port 1 is simple IO always. Okay, right. So we have 4 8-bit port. So all the port upon reset are configured as a output. Okay, when applying the reset, all the port is configured as output, ready to be used as an input port by external device. Okay, right. Then port 0. So port 0 is also designed as designed for AD0 to AD7. When the connecting 8051 to external memory, the port 0 provide both address and data. Okay, provide address and data. In 8051 multiplexer multiplex address and data through port 0 to save the pins. Okay, so here multiplexed address and data means it sometimes it acts as a address, sometimes it acts as a data. Okay, but both address and data is flowing through this lower bit address are flowing through this port 0. This ALE is used to indicate the port 0 has address or data. Okay, the ALU is indicates whether the port 0 is act as address bus or it data bus. Okay, it is controlled by ALE. Okay, when ALE equal to 0, it provided data. When ALE equal to 0, the port 0 provide data, that is a T0 to D7. When ALE equal to 1, the port 0 gives address A0 to S7. So this is a condition of port 0. Next one is a port 1 and 2. So in 8051 based system with no external memory connection, okay, there is no external memory connection means you can port 1 and 2 are used as a simple IO. There is if you are not connecting any external IO, so port 1 and port 2 act as a simple IO, input output port. Okay, and based system with the external memory connections, the port 2 must be used along with the port 0 to provide 16-bit address for external memory. So if you are connecting external memory, port 0 and port 2 completely allocated for memory address and data transfer. Okay, we cannot use it as a IO. But if you are not connecting any external memory, so the port 2 act as a simple IO. Port 2 provide the lower port not provide a lower 8-bit address A0 to A7. Port 2 provide higher 8-bit address, that is a A8 to A15. Okay, then port 2 is used for upper 8-bit address. Okay, right. Next one is a port 3. The port 3 can be used as a simple input output port. The port 3 has an additional function providing some extremely important signals. Okay, sometimes. So the extremely important signals are, so first one, that is a port 3 0th pin and one first pin, that is used for RxD and DXD. Okay, pin number 10 and 11, that is used mainly used for serial communication. If you are using a serial communication serial port, at the time RxD and DXD, that is connected in pin number 10 and 11, that is a port 3 and 3.0 and 3.1. Then port 3.2 and 3, that is used for interrupt, external interrupt. So we are having external two external interrupt, that is accessed through port 3.2 and 3.3. And port 3.4 and 5 is used for timers, that is a T0 and T1, T0 and T1, that is act as a timer. And the port 3.6 is used for write operations. Okay, write operation. 3.7 is for read operation. Both are active low. So why we are using a bar here? The bar indicates that is active low. What is active low? Generally, consider one signal. We want to switch on the particular signal, we have to provide logic 1. Okay, if you are providing logic 1, it will switch on. But in active low, that it means if you are providing 0, then only it will switch on. If you are providing 1, it will automatically switch off. It's just opposite. Okay, not. Next one, pin description summary. Okay, then other apart from some pins, we are having the basic pins, that is a VSS, that is a ground. Okay, 0 voltage reference. Then VCC, that is a power supply pin. So by using the power supply, we can provide 5 volt, in some case 3.3 volt is also available. Okay, right. So power supply voltage for normal, idle and power down operations. Then port 0 and port 1, port 2, port 3, these are the 3 ports already we have studied. Okay, right. Port 0 is open and drain bidirectional IO port. Port 0 is also used to multiplexed low order address and data bus. Okay, during access of external program and data memory. Port 1 is always 8-bit IO port. Port 2 is used for higher order address while we are connecting external data memory. Otherwise it is act as a IO port. Port 3 is a basic IO port, but it having some special features already we studied. Okay, right. Then RST, that is a reset. This pin also we have studied. Okay, so when this pin is high, 2 measure cycle while the oscillator is running, the reset the device, that will reset the device. So what happened after applying the reset? So all the registers are set to 0 0. Okay, then ALE, address latch enabled. What is address latch enabled? So the address latch enabled is used to mainly used to demultiplex address bus and data bus, that is used in port 0. Output pulse for latching the low byte of the address during access of external memory. PSE means program store enabled. So on the read strobe to external program memory, when executing code from external program memory, PSE is activated twice each machine cycle except to PSN activation. Okay, then EA and external access and VPP. What is that? Programming supply voltage, external access. So external access is to indicate the use of external memory. Okay, so these are the pin description of 8051 microcontroller. Next we are going to see some memory structure of 8051 microcontroller or memory space. So first we are going to see memory structure. So program memory. Okay, actually program memory is 4 kilobytes. The internal program memory is 4 kilobytes. So within IC we have a 4 kilobytes. If our program is less than 4 kilobytes, means we can store the program in chip directly in the microcontroller. But your program is larger than 4 kilobytes, okay, means we have to use external program memory. That is a external program memory is around 60 kilobytes. Okay, we can use 60 kilobytes of external program memory. Okay, so that is the structure. Similarly, data memory, totally we can access 64 kilobytes of external program memory. So maximum accessing capacity of external memory is 64 kilobytes. Next one is internal data memory. Data memory is 128 bytes along with a special function registers. The special function register is also used to store some particular operations. Okay, that is internal memory. Then external data memory is also 64 kilobytes. So if you want integrate our system, some program capacity and the speed of the system is increased, to increase the speed and some other features, we are using external data memory. Okay, right. The internal RAM structure. Okay, so internal RAM is consists of two things. One is a direct and indirect addressing, that is 128 bytes of internal RAM. So by using a direct and indirect addressing, we can access 128 bytes RAM. Okay, by using a direct addressing only, we can access special function registers. Okay, that is a 8-bit register. So that is used to use it for some special operations. Okay, the for special function registers, that is a MAC register, A register, B register. Okay, right. So actually the format of special function register is shown the first image. So here we are having that is number. Okay, number of particular register, then direct byte addressing, that is located here, and register name is present here. So this is a register and the memory address is A0 and that is a number of bit is 8 bit. Similarly B register, the memory address is F0, number of bit is 8 bit. Similarly PSW, program status word, the register bit is 8 bit, so it is location address is D0. Similarly stack pointer address is 81, it is 8 bit. Okay, program counter is also program counter is no access, so it is a 16-bit register, it can store the 16-bit address. Then data pointer, so the address is 82 8-bit, 83 8-bit. In some times this can be used as a 16-bit port. Next one is a timer control register, that is also 8-bit, two number of 8-bit register, that is a 88 and 89 is the address of timer control register, T mode, T-con and T mode. The next one is a timer control register, that is a TL1, TH1, TL0, TH0, that is an internal register that is used to load the time value, that is also 8-bit. The address is 8B, 8ABCD. Okay, right, this is the address. Then interrupt register, that is also 8-bit, address is A8, B8. Then special data registers, so SCON means serial port control, SBUF means serial buffer, PCON means power control. These are some special control register that is used to control the serial port, then power operations. Then port, so actually we are having the 4 port, the 4 are accessed through the registers, each having the 8-bit latch. Okay, each port having address B0, A0, 9080, 8090, A0, B0. Okay, then special function register, some of the special function register along with the addresses. So P0 is a port 0, SP means stack pointer. In the left we are having the address of the particular register. DP12 means data pointer lower, DPH means data pointer high. Then PCON means power control register, TCON means timer control register, T mode means timer mode register, TL0 means timer, that is a timer L0 and timer L1. Okay, TL1 and TH0, TH1. Okay, then 90 is a port 1 address is 90. Okay, SCON register address is 98, right? Then SBUF user in 99. Then P2 user as user in A2 IE, that is a interrupt enabled A8. Port 3 is a B0, instruction pointer B8, program status word D0, accumulator E0, B register F0. These are the address of some special function registers. So we will study this special function register in very deep later. Then program status word. Okay, already I studied the program status word. So the last bit is C, that is a carry. Next bit is like auxiliary carry. Then after that, user flag 0 and user flag 1. We are having two user flags. And then after that, overflow flag is available. So in case any overflow present in a result, so this flag is set to 1. Then parity flag is present in a data transfer if during the time of data transfer the parity is indicated, that is odd parity or even parity. Number of ones is odd means that is a 0, number of ones is even means that is 1. The next one is a registered bank select by two registers. So according to the number used in the two register, we can select the registered bank. Okay, then what are the instructions that will affect the flag registers? Mostly carry flag, overflow flag and auxiliary carry. These are the three flags are affected by the result that is indicated here. Next one, 128 byte RAM. Okay, there are 8 bit of RAM. So in the 8051, so the ascent is 0 to 7F, address is 0 to 7F. The 100 bytes are divided into three different groups as follows. Total number of 32 bytes from location 0 to 1F, that is a 1F fix or set inside the register bank and the stack. Okay, so 0 to 1F total length is 0 to 7F. 0 to 1F we are having the register bank. Each register bank can store 8-bit registers. It can store 8-bit numbers. So this is connected to register bank. Next one is a total of 16 bytes from location 20H to 2FH are set as aside bidirectional read-write memory. Okay, there is a bit addressable area. So by using address we can access this area. Next one is a total 80 bytes from 30H to 7F used for read and write storage called as scratch pad. Okay, that is for general purpose area. It is used as a scratch pad. Okay, these are the 128 bytes of RAM is allocated into three different things. There is a register bank, bit addressable area, then scratch pad. RAM with the access. Actually, this is a RAM is divided into different level. There is a register bank, then bit addressable and scratch pad. Okay, the register bank is divided into register bank 1, 2, 3, 4. Each bank consists of 8-bit registers. Okay, when we are having a 4 number of bank, each bank consists of 8 number of register like this. R0, R1, R2, R3, R4, R5, R6, R7. So these registered banks are used to store the single byte of data. Okay, register bank structure. But we can access any one of the bank at the time. So the bank value is selected by the select line that is used in the program status word. The program status word we have the select lines. Okay, register bank 0, 1, 2 and 3 like that. Programming model. Okay, so actually total number of memory space displayed here. So internal ROM, that is 00 to FF, then internal RAM, that is from 00 to 7F, then registers, internal special function registers. Okay, and basic register, everything is displayed here. So if you are doing the program, we can use the address directly to access some particular registers. So these are register bank and special function registers, bit address RAM, general purpose RAM. Okay, the next one to see the stack. The stack is used to store the data temporarily while we are executing push and pop instructions. Okay, the information could be data or address. The register used to access a stack is called as stack pointer register. The stack pointer register is 8-bit wide Okay, and in the 8051 is a 8-bit wide, which means that they take the value of 0 to FFH. When the 8051 powered up, the stack register content initially, so the stack pointer value is 07. RAM location 08 is the first location being used for stack by 8051. RAM location 8 is the first byte. The stack pointer putting the last used location is stack. As we push data into the stack point is incremented by 1. This different from many microprocessors. Loading the content of the stack back to CPU register is called as pop. So if you are executing push, data are loaded into stack. If you are executing pop, the data are loaded from stack to the destination location. Bit addressable and byte addressable. Okay, so this is a general purpose RAM. We are having the 4 banks. Apart from that, the bit addressable locations. So the bit addressable locations are indicated by one column and row. So the row is divided into 0, 0, 0, 0, 1 to 0, 7. Okay, like 0, 8 to 7F up to 7F in horizontal format, and vertically we are consider that is numbers. Single byte instructions, that is a single byte instruction, that is set B, clear, CPL, JP, JNP and JBC. These are the single byte instruction. So single byte addressable example, so which is each of the following bit block give the address of the RAM location byte is set B. So set B means set B42 means the 42 is a location. In that location we have to load the data is 1. Then clear 67H means where is 67, here is the 67H is clear to 1. Okay, so that is set to 0. Then clear 0FH, clear 0FH means here is the, so this is to clear this value. Okay, so similarly set B28, clear 12, set B5, etc. Everything is used to set or reset the data in particular locations. Okay, so thank you students. So up to this we studied the signals and the memory structure of 8051 microcontroller. Actually it is, I think it is very useful to you. Okay, so thank you friends, thanks for watching. Please subscribe if not you subscribed still now. Okay, and share and like this video. Okay, thank you.